Okay, guys, I'm actually going to stop you where you're at. We probably won't do every single example either because we're going to have sort of like a short presentation today. Today's focus is back on factoring. I told you that this chapter was going to be about solving problems different ways. So I created the bell work to review a couple of different types of factoring strategies. So using these 6 or 7 factoring strategies on the board, did you guys recognize the first one? What was the first one? So that's what a lot of people say. A lot of people think it's a difference of squares, and if it was, we would be able to square root it, right? But 6 doesn't have a square root. Square root doesn't mean to divide by 2. So it actually isn't a difference of squares. Yeah, so basically if it fails, it means that there's probably going to be a GCF. Did you guys find what the GCF was? So it's just going to be a 2x. So we pull out the 2x using division, and then we're left with 3x minus 1. There's your answer. So remember also yesterday I was trying to emphasize factoring versus solving. This is just factoring because we don't say x equals. Okay, number 2. What type of factoring strategy do we have to use for number 2? That's going to be a simple ABC. Now, simple ABCs are kind of my favorites because all we do is make the list for the final number and then try to find something that makes 3. So it's got to be 1 and 4, and then to get the signs to work out right, it would have to be -1, +4. So the thing about simple is once you have that number circled in your list, you can go straight into your answer. So we put an x in each one, we put -1 in the first one, and then +4 in the second one. What type is the third one? Okay, so in a complex is a little bit more work because we have to convert it into a different type of problem. We have to convert it into grouping. So with complex, we multiply the first and the last. We make the list, 1 and 6, 2 and 3. We're trying to make 7 so we can replace it. So it's got to be 1 and 6, and it's going to be positive, positive. So we replace the positive 7x with plus 1x plus 6x, and then we put the first and last term back on. So we put 2x squared here and plus 3 over here. So now we can do it by grouping. So we take out the GCF of the first set, which I believe is x. So we're left with 2x plus 1. And then in the second set, I think we can divide it by 3. Whoa, what's happening on this side of the board? We divide it by 3 and we're left with 2x plus 1. So when we write our final answer, we're going to have one parenthesis that says 2x plus 1. And then the other parenthesis is going to say x plus 3. And it doesn't really matter which one you put first. Multiplication is commutative, so order doesn't matter. So those are our 3 review problems, and that's actually going to lead into what we're going to talk about today. Oh, I forgot about number 4. Number 4, it's like a riddle. It says, I'm thinking of 2 numbers whose product is 0. Tell me what one of the numbers is. You guys know what a product is? Product is the answer to a multiplication problem. So I'm asking you, if I have 2 things that are being multiplied, and we know that the result is 0, what can you tell me about one of those numbers? Yeah, one of them is 0. So that's actually, that riddle right there is actually the 0 product property rule. The 0 product property says if you have 2 things that are being multiplied, so I'm going to put it as a, kind of like the stuff you saw in geometry. If A times B equals 0, then A equals 0 or B equals 0. That's awful hard. So if you've got 2 things that are being multiplied together, either the first one is 0 or the second one is 0. So we're going to use that idea because in factoring, when we factor something, we rewrite it as a multiplication problem. And so we're going to use that as our advantage to solve for our x's. So I'm going to show you an example of what I mean as far as like the 0 product property. Bless you. So let's say I already did all my factoring and I ended up with this. X and x plus 4. But now I actually want you to solve. Now, when we have problems, and this is an example, by the way, I just made it up. when we have problems, they don't look like this. They look like the problems that you saw in the bell work. So it's our job to rewrite them so you can see each of the separate x's so that you can solve them separately. So what we do is we just say equals 0. Now there's two x's here, right? So that means we should have two answers. So using the zero product property rule, all we have to do is take each part that has an x and set it equal to 0. So that means that one of these answers is x equals 0. Now the other part has a little bit of work to it because it's not all by itself. So it's going to say x plus 4 equals 0. So we subtract 4, and we end up with x equals negative 4. So those are our answers. And that's essentially what we're doing today. Today's lesson is called solving by factoring. So we're going to use the factoring skills that we learned in the last chapter to separate all the x's so that we can solve each one individually. So 3 basic steps. I don't know why it keeps going to the highlighter, but we have 3 basic steps when it comes to solving by factoring. Step 1, whatever the equation is, you're going to set it equal to 0. You may or may not see problems that are already equal to 0, but if they're not, just move everything to one side, then it will equal 0. Second, factor. Third, set each part equal to 0, and then solve for each x. Now that's pretty much what we did in that example underneath where it says zero product property. I had a problem, I factored it, set it equal to 0, and then solved for each x. So if you guys think about it, what factoring does is it takes like an x squared and separates them into 2 separate x's. So we want to separate all of our x's so that we can find an answer for each one. You're also going to notice the strategy that we learned yesterday, it will not work. Yesterday's strategy only worked if your problem is full of x squareds. In these problems, you're going to have x squareds and x to the first. So you can no longer use the square root method. So we're going to kind of zip through a couple of examples here. If you look at that first one's my favorite because the first one, it's already factored. We don't have to factor it. So we're ready to solve. So we take this first part and we set it equal to 0. So there's one answer. Then we take this second part. Oh my gosh, I messed up. Did you guys notice that? Look at what it's equal to. Yeah, we can't set it equal to 0 if it's equal to 3. So before we do this, we actually have to not factor it out, but multiply it out and get the 3 over. Oh man, I was excited. I thought I was ready to go. So let's see. On this one, we're going to have to kind of multiply it out first. So we have 2x squared, and then plus 5x equals 3. And then we need to subtract the 3. So I'm going to squeeze it into that spot right there. So we have 2x squared plus 5x minus 3. So I almost fell for it. These problems are supposed to equal 0. So now we can factor and solve it. So what type of factoring method would we use here? It's a complex ABC again. So in a complex ABC, we multiply the first and the last. So we get negative 6, 1 and 6, or 2 and 3. We're trying to make 5, and both of these could possibly make 5. But only one of them is going to multiply to a negative 6. So if I have a negative 6, that tells me that one has to be a positive and one has to be a negative. So that means it has to be this one. To make a positive 5, it would be negative 1 plus 6. So I use that to replace the 5x. So I have minus 1x plus 6x. Then I bring down the 2x squared and the minus 3. Now we can do this by grouping. I was just checking. I thought maybe that was one of the bell work questions, because then we could have saved a lot of time. So we're going to do this by grouping. So I take out the x. I have 2x minus 1 plus, I take out the 3, 2x minus 1. So I'm left with 2x minus 1, and then x plus 3. Now we're not done yet. That's just the factoring part. The factoring is done to separate the x squareds. So now we have separate x's, so now we just solve each part separately. So we do 2x minus 1 equals 0. So I'll solve that real quick. Add 1 to both sides. Then divide by 2. So x equals 1/2 is one answer. Bless you. Then we take the second part, set that equal to 0, and solve that one. So x equals -3. Those are our two answers. I think I'm actually going to skip the example that's on the right side. It's just a GCF problem. There's not a whole lot to it. So let's go ahead and flip over to the next page. Let's look at a couple more of these guys. So again, I'm going to cut this a little short because I want to get to that presentation also. Let's just make sure we hit a couple of these different types of factoring methods. So let's do this one right here. What type of factoring method would we use for that one? It's a simple ABC, my favorite. Simple ABC uses the last number. We make the list. It's all plus. So it's all +1, +7. We can go straight into the parentheses, put the x's, and then put +1 and +7. So now we just take it that extra step since we're solving. Set up two separate problems. So you got x plus 1 equals 0 and x plus 7 equals 0. So x equals -1 and x equals -7. Hey, have you guys noticed a pattern yet? Look at what's in the parentheses and then look at what we write. You guys notice that pattern? Just changes signs. That's all it does. Now you will have to be careful though if there's ever an x in, a number in front of your x, because then that just means you're going to end up with a fraction. Let's see what else we got here. Let's do, we'll do these bottom two. So let's see what we got here. This looks like another simple ABC. So we're going to make the list for 36. Now, I'm just thinking about this because that's a 12 in the middle. Two numbers that multiply to 36 and add to 12. 6 times 6. And that whole problem is positive again. So in a simple ABC, we can go straight to the parentheses. So we got x plus 6 and x plus 6 again. So we're going to get two answers. But because I'm lazy, I'm not going to show the work for the second one. If your parentheses match exactly, you don't have to do it twice. Just do it once and then write it again. Now, even so, like you don't even have to write it twice. We call this a double solution. This is supposed to have two answers. It's just that both answers are the same. Because remember yesterday I told you there's going to be a pattern between the exponent and how many answers you have. If it's x squared, we should have two answers. So this is still two answers. It's just they're the same. And then finally, the last one. The last one is, let's see what we got here. What kind of, oh, I can't see it. What kind of problem is this one? Difference of squares. Now, difference of squares has a shortcut. We know that the answer to these kinds of problems are supposed to have 1 plus and 1 minus. You guys remember how to come up with the stuff on the inside. You just square root it. If you square root x squared, it gives you x. If you square root 49, it gives you 7. The second parentheses looks exactly like it. So then we can set each one equal to 0. X plus 7 equals 0. X minus 7 equals 0. So I subtract 7 from both sides. So one of them is negative 7. Then I add 7 to both sides. The other answer is positive 7. So what do you guys think about this stuff? Not that bad, right? It's still all the stuff we tested on in the last chapter. It's just we got to take it that extra step, and we got to solve it. Before I hand it over to Ms. Rubio for her presentation, I want to talk about one more thing, because this confuses a lot of people. Let's pretend I already factored. Let's say I'm done factoring already. So I finished factoring, and I ended up with this. My question to you guys is, how many answers am I going to have? See that? I just paused a little bit, and then I got 2 different answers. Some people think there's going to be 2 answers. Some people think there's going to be 3 answers. You know how to tell? How many x's do you have? There's only 2 x's. We should only have 2 answers. So this problem, the answers would be negative 3 and positive 5. And the thing that was throwing you off was this guy, the 2 in the front. The 2 in the front was a GCF, but we don't really care about it because it doesn't have an x. Our goal here is to solve for all of our x's. So since it doesn't have an x, we just ignore it. Now, if our GCF did have an x, like if that was a 2x, then we should have 3 answers. And guys, usually if you have an x in the very front with that 2, I don't care what's in front of it, it's going to be 0. Because think about it. Let me add the x. If I have an x on this, no matter what, set it equal to 0 and solve it. You're going to end up dividing, and it's still 0. So if you ever see an x in the very front, it's always just going to give you an answer of 0. And that's overall, that's it. Now, I will warn you, you may see any of those 7 methods that we know. What is it called? Complex ABC, grouping. You will see a lot of difference of squares. Sometimes, actually, I want to say this too. I think this is important. Let's see if you guys recognize what type of problem this is, if it's already been factored. Do you guys recognize what type of answer this is out of these 7 choices? It's the cubes one, right? So I'm going to ask you this question. How many answers should we have? We should have 3. Because there's this x, and then there's these 2 x's. Because it's x squared. But here's the problem. This section right here is going to give us some i's. I promise you, I guarantee you. In every cubic problem, this second set of parentheses is going to result in imaginary solutions. The only real solution we're going to get is from this set. So we do x minus 3 equals 0. So it says x equals 3. So when you guys read the directions, it's either going to say find all real solutions, or it's going to say find all solutions. Now at this point, you guys are not going to know how to get the 2 answers out of this because there's another method to do it. That can never be factored, and that's not a square root problem, and those are the only 2 types that you know so far at this point. So that's just a heads up. We'll talk about that a little bit more when we see it a little bit more.